Göbekli Tepe turned out to be what you think it might have been, the place where advanced ancient civilization once inhabited, or they used it.
Göbekli Tepe was a game changer, but I think it's a game changer for everything, because Göbekli Tepe, the extraordinary nature of it, we're looking at a major megalithic site, which is at least 5,500 years old.
The limestone rings at Göbekli Tepe have always looked like they were set down with the calm confidence of people who already understood stone, space, and ceremony at a level that does not fit our usual picture of the early Neolithic. T-shaped pillars rise like stylized human presences, their faces turned inward toward a shared center, their sides alive with carved foxes, boars, snakes, and birds.
And then if we look at them, they're covered in these engravings. So this is a fox.
For years, the most stubborn mystery has not been what these enclosures meant, but how they were physically made by communities without metal tools, wheeled carts, or domesticated draft animals. New AI-assisted 3D scanning has pushed that question into sharper focus by doing something human eyes and even careful excavation notes struggle to do at scale. It links thousands of tiny surface clues into a single, coherent construction story. Before we start, hit the like and subscribe buttons for more exclusive news.
These pillars dates back 11,600 years. It appears to be purposely buried at the same time of the Younger Dryas climate catastrophe. This is fascinating.
The first revelation comes from the stone itself, and it is almost intimate. High-resolution scans pick up micro-topography along pillar flanks and relief carvings. Shallow ripples where a tool bit, faint crescents where a blow glanced, subtle polishing where hands and ropes repeatedly rubbed. When machine learning models are trained to recognize these textures across the site, patterns pop out that are hard to see in isolated patches. Certain tool signatures cluster on specific faces of pillars, implying that many blocks were worked while still lying in a predictable orientation, likely close to the quarry. Other signatures cluster at consistent heights, suggesting standardized working postures or platforms. This does not just say people carved stone, it shows a workflow, a repeatable routine, and a division of labor that was disciplined enough to leave a recognizable fingerprint in the rock. Equally striking is what the scans reveal about quarrying. Göbekli Tepe sits in a landscape of workable limestone, and surface mapping can trace scars and extraction negatives in the bedrock around the enclosures. AI pattern detection can identify the telltale geometry of wedges and lever points, distinguishing natural fractures from deliberate cuts. Across multiple extraction areas, the same geometry repeats, implying shared technique rather than improvisation. The models also highlight partial pillar blanks and abandoned cuts, whose dimensions match finished pillars within a tight tolerance. That matters because it points to a mental template. People were not just hacking out whatever was easiest, they were committing to a predetermined form repeatedly as if the architecture demanded specific proportions. One of the most persuasive pieces of the new picture is the chain from quarry to enclosure. By combining scans of the bedrock, terraces, and subtle depressions between working areas, AI reconstruction can propose likely transport corridors that follow the easiest gradients and avoid pinch points. The pathways are not dramatic roads, they are gentle, practical lines where repeated movement would compact soil and erode edges. When these candidate corridors are compared with the locations of quarry scars and the orientations of the enclosures, the lines begin to look like a logistical plan. It suggests that builders preferred predictable routes and that those routes influenced where certain rings were positioned. Instead of imagining each enclosure as an isolated inspiration, the scans encourage seeing the whole hill as a managed worksite, with extraction zones, staging areas, and movement lanes that reduced friction in a heavy lifting economy. The stones themselves also carry evidence of how they were moved. On some pillars, scanning can pick out long, shallow striations that run in parallel bands, the kind of marks consistent with dragging against gritty surfaces or with rope contact under tension. AI classification helps separate those from later weathering by matching mark geometry across multiple objects. Where the bands concentrate on particular edges, it implies preferred rigging points and consistent ways of fastening. That points toward transport methods like sledges over lubricated paths or dragging over prepared tracks of packed earth and limestone chips. The beauty of this is that it does not demand anachronistic machinery. It is the physics of friction and leverage, made legible by pattern recognition across the site rather than by a single dramatic artifact. Then there is the ground preparation, which the scans make feel almost modern. The enclosures sit on carefully shaped bedrock platforms, and in places the floor is smoothed or subtly leveled. With dense 3D data, AI can detect minute slopes and micro-drainage channels that a casual view would miss. Some floors are not perfectly flat, they are intentionally biased, perhaps to shed water away from pillar bases or toward a central low point. That implies forethought not only about how the space looked, but how it behaved. It also implies that the builders understood that a heavy vertical stone needs a stable base, that water undermines, that freeze-thaw pries. Those are lessons you learn by building, not by accident, and the scans hint that this knowledge was already baked into the earliest phases of the architecture. How the pillars were set up right is where the new reconstruction becomes most vivid. When AI compares the geometry of pillar sockets, it can sort them into subtypes: narrow slots with specific tapering, broader pits with flat ledges, sockets with slight ramps on one side. The distribution of these subtypes suggests different erection strategies. A socket with a gentle ramp and a tightening taper looks like it was designed so a pillar could be slid in at an angle and then levered upright, settling into a snug fit as it rotated. A socket with a ledge implies a staged support point, like a temporary rest as the stone pivoted. Once you see these patterns repeated, it becomes hard to dismiss them as incidental. The architecture begins to read like a set of instructions carved into the ground. The scans also highlight something that feels like the missing step between hauling and standing: temporary construction features. In high-density terrain models, slight berms and shallow cutbacks around enclosures can be distinguished from natural undulations. AI can flag these as anomalies with consistent shapes and positions, suggesting they were ramps, working platforms, or spoil piles deliberately placed. Even if those features are faint today, their geometry can still be reconstructed. The implication is that builders likely created earthen ramps to bring pillars close to their sockets, then used teams of people on ropes, levers, and counterweights to rotate the stones into place. The process is demanding, but it is not mysterious. It is the logic of communal engineering, scaled to what human muscle and simple tools can do when organized well. Once the pillars were upright, the next problem was keeping the ring coherent and stable. Here, the scans point to subtle standardization in how walls and benches were assembled. AI comparison of wall stone shapes can detect recurring module sizes, suggesting that certain stones were selected or trimmed to fit a preferred thickness and height. In some places, the way stones interlock hints at an understanding of load distribution, with larger blocks anchoring corners and smaller packing stones locking gaps. That kind of masonry does not require written math. It requires repeated practice and a shared sense of what holds. The 3D data makes it possible to measure wall batter, curvature, and consistency across multiple enclosures, and the result is a picture of builders who were not experimenting randomly, but repeating a proven recipe. The carvings themselves become evidence of sequencing. On certain reliefs, scan-based analysis can show that background surfaces were flattened before animal forms were raised, and that final detailing was added after the pillar was largely shaped. More importantly, the distribution of fine finishing marks can indicate whether carving happened before or after erection. If delicate marks appear in areas that would have been hard to reach once a pillar was standing inside a tight ring, that suggests pre-erection carving near the quarry or at a staging ground. If other marks concentrate on faces that would be most visible to participants inside the enclosure, that suggests on-site finishing to adjust composition and prominence. The result is a hybrid workflow: heavy shaping and much of the iconography prepared off-site, then final tuning done in place to suit the space and the audience. One of the most consequential implications of this AI-driven reconstruction is that it makes planning unavoidable. The geometry of the rings, the spacing of pillars, and the consistent relationship between central monoliths and peripheral posts point to layout methods that were repeatable. The scans let researchers Reconstruct arcs, center points, and alignments with far greater precision, and AI can test which simple construction techniques best reproduce what is observed. Patterns consistent with rope and stake geometry emerge. Circles and ovals that could be laid out by a cord anchored at a fixed point, or by multiple reference points creating a controlled ellipse. This implies that builders had a toolkit of spatial procedures. They did not need formal geometry as a written discipline. They needed shared know-how, how to measure, how to keep symmetry, how to correct drift, how to translate a mental image into pegs in the soil. This planning also shows up in the relationship between sculpture and architecture. The T-shape is not just a convenient form, it behaves structurally, offering mass where needed and a silhouette that reads as anthropomorphic. AI analysis of proportions suggests that the headpiece width, shaft thickness, and base dimensions often follow a narrow band of ratios, which would help with stability and visual consistency. If those ratios were intentional, they imply design constraints. The pillars needed to stand safely, look right, and fit into a ring with predictable spacing. That combination of structural and symbolic demands is the hallmark of mature building traditions. The scans do not make Göbekli Tepe suddenly modern, but they do make it feel less like a one-off miracle and more like the product of accumulated competence. The labor story changes too, and in a way that is more interesting than simply saying it took many hands. AI reconstruction makes it possible to estimate weights more confidently by modeling pillar volumes and accounting for missing or damaged portions. When those estimates are paired with plausible friction coefficients and slope gradients along likely transport corridors, you can derive realistic ranges for how many people would be needed at each stage. The event this creates in the mind is not a faceless mass of workers, but coordinated teams with specialized roles. Quarry crews extracting blanks, shaping crews roughing out forms, hauling teams managing ropes and sledges, ground crews preparing sockets and ramps, and finishing artists carving and polishing. That division of labor suggests leadership, scheduling, and the ability to mobilize effort around shared goals. Because the site predates widespread agriculture in the region, that mobilization has implications that reach beyond engineering. If hunter-gatherer or early sedentary communities could coordinate repeated construction projects of this scale, it implies social structures capable of sustained cooperation without the typical agricultural surplus model we often lean on. The scans reinforce this by showing standardization and repeated methods across multiple enclosures, which hints at continuity over time and a tradition passed between groups. The event, in other words, is not simply that stones were moved, but that knowledge moved, techniques, measurements, iconographic conventions, and the subtle craftsmanship of making limestone behave. It suggests that complex ritual architecture could be a driver of social integration rather than a luxury that appears only after farming is secure. The implications for how we imagine early religion and community life are immediate. The architecture reads like a stage designed to shape attention. Tall pillars framing sightlines, carved animals emerging in low light, central monoliths anchoring the experience. If the construction sequence involved bringing large carved forms into a prepared ring and setting them upright in a coordinated effort, then the building process itself could have been a powerful communal act, a performance of cooperation and shared meaning. The scans do not tell us the beliefs, but they clarify the deliberate nature of the setting. Nothing about the sockets, ramps, and standardized proportions feels accidental. The place was made to be convincing, to feel inevitable, to make participants feel that these stones belonged exactly where they stood. There is also an implication about cognition that is easy to miss if you focus only on brute strength. The AI-driven picture emphasizes iterative refinement. Decisions made at the quarry based on templates, adjustments made at sockets based on fit, finishing touches made based on visibility and effect. That kind of work requires mental modeling, not just muscle. It requires being able to imagine the final enclosure while you are still staring at a rough block on a hillside. It requires communication across tasks. The person carving a relief needs to know how high the pillar will stand and which side will face inward. The person cutting a socket needs to know how wide the base will be and how much clearance is needed for rotation. This is collaborative design thinking, expressed without blueprints, but still recognizably designed. The new 3D scan-based reconstruction also pushes back against the temptation to treat Göbekli Tepe as an inexplicable anomaly. When AI pulls coherent patterns from hundreds of small marks, it gives mundane explanations their proper weight. Levers leave consistent bruising on stone, ropes leave consistent abrasion, ramps leave consistent microslopes, templates leave consistent proportions. What looked mysterious when viewed as isolated marvels becomes understandable when viewed as a system. That does not make the site less astonishing. It makes it more human because it credits the builders with practical intelligence rather than attributing their achievements to lost civilizations or impossible technologies. At the same time, the event of these scans is not only about demystifying the past, it is about expanding what we consider plausible for early societies. If a community can repeatedly quarry, shape, transport, erect, and decorate multi-ton stones using stone tools and organized labor, then the boundary between simple and complex shifts. It becomes harder to argue that monumental building requires kings, armies, or formal states. It becomes easier to imagine networks of communities sharing techniques, gathering seasonally, and investing in places that anchor identity. The implications ripple outward. Other early sites may deserve a second look, not because they must be monumental too, but because the capacity for sophisticated planning and coordinated labor may have been more common than our old categories allow. What the AI-assisted scans ultimately reveal about how Göbekli Tepe was made is a sequence that feels both rigorous and alive. Limestone selected and freed with repeated methods, pillars shaped with standardized ratios, iconography carved with a blend of off-site preparation and on-site refinement. Routes chosen to reduce transport friction, ramps and platforms used to turn heavy stones into manageable pivots, sockets engineered to guide erection and lock stability, walls assembled with modular consistency, and floors shaped with attention to behavior as well as appearance. The implications are not an ending. They are a sharpening of the question we should have been asking all along, not how did they do it as if it were impossible, but what kind of people do you become when you can do it again and again with nothing but stone, wood, fiber, and a shared reason to pull in the same direction. Another layer of meaning in these scans comes from how they turn tool use into something closer to a signature of hands and habits. When AI sorts microchipping and percussion patterns across different surfaces, it can separate broad classes of actions that otherwise blur together. Decisive heavy blows, controlled pecking to roughen a plane, delicate finishing taps, and smoothing that looks less like carving and more like patient abrasion. That matters because it implies a toolkit that was not generic. Even without metal, the builders likely distinguished between edges meant to fracture, points meant to peck, and abrasive stones meant to wear down high spots, choosing the right implement for the right stage. The implication is a craft tradition where people knew what kind of mark they wanted before they made it, and could reliably produce that mark across many stones. Skill becomes visible as consistency, not as spectacle. The scanning also reframes time as a construction resource. Tiny mismatches in fit, minute reworking around joins, and subtle resurfacing patches suggest that building was not a single uninterrupted push, but a rhythm of episodes. AI can detect places where a surface was re-leveled or a wall segment was subtly reseated because the texture changes and the micro-relief shifts direction. This does not have to mean later repair in a dramatic sense. It can mean pauses and returns, moments when a team came back to finish a segment, correct a drift, or adjust a detail to match the whole. The implication is that the builders managed continuity of intent across time, keeping a plan alive in collective memory long enough to maintain coherence. That kind of continuity implies shared leadership or shared ritual obligation that could carry a project forward even when daily subsistence demands attention elsewhere. There's also a strong logistical story in what is missing from the stone record, and AI helps make absence speak. If pillars were erected in tight spaces, then some actions must have happened before certain constraints existed. By simulating reach, clearance, and work angles inside the scanned geometry, AI can show which carving positions would have been nearly impossible after erection, and which would have been comfortable. The implication is that builders sequence tasks to exploit open space early then shifted to tasks that benefited from the enclosure's final shape later. In other words, the architecture was not just a final product, it was a changing work environment. This invites imagining the hill as a living workshop, where the act of making altered what could be made next, and where decisions were taken with a practical sense of future constraint. The event also has implications for how knowledge moved through a community. When AI finds the same minute procedural pattern on different stones, say a consistent way of finishing an edge, or a repeated micro-bevel that smooths a vulnerable corner, it suggests teaching. Not teaching in the abstract, but in the simplest, most human form. Watch me do it, now you do it, keep doing it until it looks right. Such repetition hints at apprenticeship, at people who became reliable specialists, and at standards that were socially enforced. Standards do not require writing, they require agreement. The implication is that Göbekli Tepe was not only a place where stones stood, but a place where expertise was cultivated, where skill had social value, and where the community could recognize and reward competent work because the results were visible to everyone who entered the ring. The scanning's precision also opens a new window onto movement and experience inside the enclosures without needing to claim certainty about beliefs. By analyzing the 3D geometry of walls, benches, and pillar spacing, AI can map probable circulation routes, where a person could pass comfortably, where passage narrows, and forces single-file motion, where bodies would naturally stop. This has implications for how gatherings were structured. If movement is channeled, then access to certain views becomes controlled. If sight lines to central pillars are framed, then attention is guided. If edges invite sitting, then prolonged presence is encouraged. The architecture becomes a behavioral instrument. The builders were shaping not only stone, but social choreography, creating spaces that encourage particular forms of gathering, waiting, watching, and perhaps synchronized action, all of which reinforce a sense of shared participation. Sound is another dimension where detailed geometry matters. Rounded stone surfaces, enclosed rings, and uneven reliefs can create distinctive acoustics, and 3D models make it possible to explore how voices, drumming, or percussive stone sounds might carry. Even without claiming an exact reconstruction of performance, the implication is that the builders could have noticed how sound behaves in these spaces and valued it. A place that holds and shapes sound becomes more than a backdrop. It becomes an active part of a communal event, amplifying certain tones, dampening others, and making collective vocalization feel larger than the individuals producing it. If the architecture was designed to intensify presence, visual and auditory, then construction choices gain another layer of purpose. Curvature and enclosure are not merely structural, they are experiential. Light, too, becomes newly legible when surfaces are captured in high detail. Shallow relief can appear flat under noon sun and dramatic under angled light. A carved animal can seem to move when shadows shift across it. AI can use the scan geometry to model how low-angle sunlight could animate specific motifs at specific times of day. Not as a mystical claim, but as an optical fact, relief depth and surface orientation determine shadow behavior. The implication is that builders who spent time at the site would have learned how their carvings perform under changing light, and could have positioned motifs where they come alive. Even if the builders did not formalize this as design, repeated observation could guide choices. The enclosures could have been tuned to produce moments of visual intensity that feel like revelation to participants, reinforcing the emotional authority of the space. The carvings themselves, treated as datasets rather than isolated masterpieces, also gain implications about relationship to the surrounding world. AI can compare motif placement, orientation, and relative prominence across pillars, revealing patterns that suggest thematic clustering rather than random decoration. If certain animals tend to appear on inward-facing surfaces or near points where people enter or sit, that implies the imagery was curated to meet viewers where it mattered. This shifts interpretation from art as ornament to art as instruction, not necessarily in a literal sense, but as a structured message about what kinds of beings, dangers, or powers belong within the ritual arena. It also implies deep ecological familiarity. To carve an animal convincingly and repeatedly is to know it, to track it, to live beside it. The architecture becomes a node where lived landscape knowledge is transformed into enduring symbolic form. The physical requirements of construction carry implications for broader resource organization that go beyond the stones. Raising large pillars requires not only muscle but rope, and rope requires fibers. It requires anchor points, and anchor points require sound timber or stone fixtures. It requires food and water for workers and participants. The scans cannot directly show a rope, but they push us to recognize the invisible infrastructure that must have existed. The implication is that early communities could mobilize supply chains, gathering plant fibers, twisting cordage, selecting wood, preparing hauling surfaces, provisioning groups. This does not mean a centralized bureaucracy, but it does mean coordination over multiple resource domains. The hill, in this view, stands at the intersection of many skills: foraging knowledge, cord-making craft, woodworking, stoneworking, and the social ability to assemble these into a single focused effort. Another implication concerns authority, but not necessarily the kind that later states display. When builders commit to monumental projects with standardized methods, someone or something is setting expectations. The AI-assisted reconstruction makes it harder to imagine purely spontaneous building. Yet the form of authority could be distributed. Elders who guard ritual knowledge, master craftspeople whose expertise carries weight, charismatic leaders who persuade, or collective norms that make participation obligatory and meaningful. The key implication is that persuasion and coordination were strong enough to channel effort into making spaces that likely did not directly produce food. That suggests a social world in which meaning, identity, and shared ceremony were powerful motivators, perhaps even strong enough to bind otherwise independent groups together into periodic collaborations. The event also touches how archaeologists can think about intention versus happenstance. Before these scans, many claims about construction sequence or technique could be criticized as interpretive leaps from sparse evidence. AI-supported patterning changes the balance by elevating repeatability. When the same microgeometry appears across different sockets, the same finishing pattern appears across different pillars, the same subtle leveling bias appears across different floors, it becomes less plausible that these are accidents. The implication is methodological. The field can move from debates driven by a few iconic features to arguments grounded in site-wide statistical regularities. That does not remove interpretation, it disciplines it. It encourages questions like, what design choices are consistent enough to reflect shared rules, and what variations reflect local improvisation or differing teams? This has direct implications for how early monumental sites elsewhere might be revisited. If a place has been dismissed as too irregular or too eroded to yield construction insights, high-resolution scanning and AI classification could still recover hidden order. Faint extraction negatives, near-erased leveling, subtle socket tapering, microscopic finishing patterns. The implications are not about declaring new marvels, but about recognizing that early builders may have left systematic traces even where the eye sees only ruin. This could broaden the set of sites considered technically informative, not just visually impressive, and could help balance attention away from the few famous monuments toward a wider landscape of craft traditions and building experiments. The event also highlights a different kind of humility. AI does not solve Göbekli Tepe by itself, but it changes what can be asked responsibly. With detailed models, hypotheses can be tested against geometry rather than argued as stories. A proposed erection method can be simulated against socket shapes and clearances. A proposed layout method can be checked against circularity and center drift. A proposed work sequence can be compared against which surfaces show finishing and which remain rough. The implication is that future discussion can be less about what feels plausible and more about what fits the physical constraints revealed in the scans. This is a shift from narrative persuasion to constraint satisfaction, which is especially valuable for prehistory, where texts cannot settle disputes. At the same time, the event has implications about the limits of the evidence that the new tools make visible. A micromark can tell you that an edge was abraded. It cannot tell you whether the person doing it felt pride, fear, devotion, or boredom. A modeled pathway can suggest where heavy movement likely occurred. It cannot tell you whether that movement was festive, solemn, coerced, or competitive. The important implication is that better measurement sharpens the line between what can be inferred physically and what remains open culturally. Paradoxically, this can make interpretations of meaning more responsible, because they can be anchored to a clearer understanding of how the place functioned materially. The event is a reminder that imagination is most powerful when it respects constraints. Finally, there is an implication about why this kind of revelation feels so gripping right now. Seeing Göbekli Tepe through AI-assembled detail forces a confrontation with our own assumptions about progress. The stones do not flatter a linear story where complexity arrives only after farming, or artistry only after metal, or engineering only after writing. The scan-driven reconstruction suggests that humans were already capable of combining practical physics, careful measurement, aesthetic control, and collective coordination into a single project that reshaped their landscape. The deeper implication is not that the past was secretly modern, but that human capacity has long been broader than our categories. Göbekli Tepe, made newly legible in its making, becomes less a riddle and more a testament to what organized attention can do, even at the very start of settled life. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us? What are your thoughts on AI scans revealing Göbekli Tepe? We want to hear from you. Thank you for watching, and see you next time.